It's STEAM time. It's STEAM time. It's STEAM time. Hey, hey. It's STEAM time. It's STEAM time. It's STEAM time. Hey, hey, hey. STEAM scholars, last week was all about lights and color. Light is a form of energy that makes vision possible. Energy is the ability to do work. We learned that there are 3 different types of objects that light can and cannot travel through. A transparent object is an object that all light can pass through, and you can see to the other side. A translucent object is when only some of the light can go through an object. Lastly, any object that doesn't allow any light to pass through and blocks the light is known as an opaque object. We see light by invisible waves called electromagnetic waves, which are forms of moving energy, which is the ability to do work, that helps us see color. And in order to see color, we learned that those same waves move either fast or slow and are long or short, depending on the color we see with our eyes. You also had the opportunity to explore each color of the rainbow, known as Roy G. Biv, through a prism. A prism is a special piece of glass or any see-through material that bends light and helps us see each color of the rainbow. The white light from our light source, the sun, gives us the ability to see those colors through the prism. White light is a mix of all the colors of the rainbow. Last week, you created your own insect that lights up. We learned about insects that light up called fireflies, an insect that has a special chemical reaction that takes place in their lower abdomen that causes it to light up. Today, we will explore more about color by starting off with a class project. Before we begin, we will start by going over the design process, followed by saying what STEAM stands for. The design process is something we as engineers and scientists will use every time we create or do an experiment. Feel free to say each step with me. With any project, we are going to A, ask, what is the problem or what am I trying to create or solve? B, brainstorm. How can I solve or make what I am trying to create? C, collect. I will collect information, data, or use prior knowledge to help me create. D, develop. Start creating your project. E, evaluate. What works? What doesn't work? And what can I do to make it better? F, fine-tune. I will try again until my design is where I want it to be. STEAM stands for science, technology, engineering, art, and math. Great job! Now let's explore with today's challenge. We know that light helps us see color by electromagnetic waves. How do you think we are able to see certain colors? Take some time to discuss with your class now. I am so proud of you all's discussion. I know you guys had great ideas. As we know, electromagnetic waves and light from sources like the sun helps us see color. We also know that those same waves move fast or slow and are long or short, depending on the color of the object you are looking at, is reflecting. Reflecting means to throw back without absorbing. An example would be of you looking in the mirror. The mirror throws back the image of your face. Absorbing means to take in. This all relates to color because we see color by absorptions and reflections. For example, my shirt is yellow because it is reflecting yellow and absorbing all the other colors. This green marker is reflecting green and absorbing, taking it all in, all the other colors. What objects can you find in your classroom that are reflecting red and absorbing all the other colors? What object can you find in your classroom that is reflecting blue and absorbing all the other colors? Whoa, you guys are so good at this. Pat yourself on the back. Let's do a quick class project to learn more. For this class exploration, you will need 1 paper towel each, markers, 1 measuring cup. Be careful with your cup as you will need it for the next project. Water. And that is it. So step 1, choose a color you would like to color on your paper towel. Step 2, you are going to color the middle of your paper towel with a marker. Make sure you color it really well and leave a space in the middle empty, and then color the other side. Step 3, we are going to place 1/3 cup of water in your measuring cup. A lot of you asked in our student question box, Miss Wilson, how do you do math? Well, my STEAM scholars, you are doing math right now. Amazing, right? So measuring things with a ruler or a measuring cup is all a part of math. Congratulations. So we are going to look for the 1/3 on our measuring cup, and then we are going to pour some water. Stop. All right, you can do this as a class or with one partner, and you're gonna take your cup and your partner's cup, and an empty cup. And you're gonna place one end of your paper towel in your cup and the other end of your paper towel in a classmate's cup. Let me take one of my paper towels. And if you need more water, you can pour more water in there. Fill it up to the 1/2 cup. And then you're going to keep going until each student has their end of the paper towel in their cup and one end of their paper towel in a classmate's cup. Or again, you can do it with a partner or a group of 3, whatever you choose. You're going to set this aside and watch throughout the day as the water absorbs the colors from each of the napkins. And then you'll see what color it reflects. Write or draw what you see in your design process notebook. Now that you know more about color, it is challenge time. So for today's challenge, we are going to create our very own lava lamps. A lava lamp is an electric lamp made of transparent, which means all light can pass through it, glass containing liquid and colorful wax that changes into random shapes that rise and falls. So for this project, you will need your measuring cup, an anti-acid tablet. You will also need some oil, a plastic bottle, water. You'll also need food coloring and glitter, but that is optional. All right, so step 1, you're going to take your measuring cup and have your teacher pour oil, about a half of cup, we'll start there, of oil, and make sure you let them know when to stop, okay? So we want to fill this bottle about 3/4 of the way with oil. So our bottle is not quite 3/4 of the way, so we're gonna pour some more oil and let's measure 1/3 of a cup this time. I think that's good. And now we're going to fill the rest of our bottle with water, but not to the edge. Perfect. And as you can see right now, the oil and the water are separating. Don't worry, we may explore this in another unit, but oil and water do not mix. So this is all awesome science. So now that the water and the oil have separated, the water is on the bottom, the oil is on the top, you are going to choose your food coloring color of choice. I'm going to use lime green, and you're going to squeeze 10 drops of food coloring into your bottle. Five, 6, 7, 8, 9, 10. And gently swirl your bottle to make sure all the food coloring is in your bottle. Now, this is the optional part where you can add some glitter to your bottle if you would like. If not, we are going to move on to step 7, and you're going to break a little bit of your anti-acid tablet and then place your tablet in your bottle and observe what is taking place. Wow, look at that. Draw what you observed in your design process notebook. So think about it. What happened to the color in your lava lamp? What do you think happened? Did the water or the oil absorb or reflect the color? We learned so much today, STEAM scholars, and what a great time we had together. Light and color are all around us, and we are able to see the colors by reflection and absorptions of the electromagnetic waves. Keep exploring what colors you see reflecting throughout your day, and write or draw about it in your design process notebook. To get started, think about what color a banana reflects. What color does the grass reflect? Lastly, like our fellow STEAM scholar from Esperanza asked, why is the sea blue? Think about what color the sea or ocean reflects and come up with ideas about why you think so. For more exploration, you will hear from your teacher as they read Light is All Around Us. Until next time, my STEAM scholars, be great and keep exploring. Bye-bye.